Okay, we have a good 20 minutes plus for question and answers. So we have, once again, roving mics going back and forth. I thought the last time we as moderators took a lot of time in asking questions. So are there any hands up? Oh, yeah, there are some hands up there. So let's go to the very back and ask the gentleman for
Is it on? Hello. Nathalie.
If you don't mind, if you could just introduce yourself and your affiliation, we
Sure.
would appreciate
My name is Tristan de Frandeville. I'm from a company called Cloudbeam, and this question is for Nathalie. So we make an ecosystem of Wi-Fi devices, and obviously Wi-Fi, they can go to the internet, but a company in America called DataJack came out with a modem, little credit card-sized modem, that uses only the 3G network. So because it's 3G only, instead of $60 a month, which is what everybody charges, 5 of our devices can go out to the internet through that modem for only $10 a month. Big economic change in what we can do when people don't have Wi-Fi, which is rare. So to use your telecom networks, you talked about 4G going to LTE and the benefits of LTE, but in the machine-to-machine world of devices, we actually want to benefit from installed infrastructure of 3G that is all we need. We don't need video. So it'd be great if there were almost 2 separate networks. So I'm just wondering, number one, as somebody at Orange, do you have a plan of leaving behind this infrastructure and making it available to machine communication? Or is there an economic reason why telecom companies would be pulling out that infrastructure and not leaving it behind for machines to communicate with?
Well, I was mentioning 4G because this is the latest deployment we have, but as you may know, we are still finalizing deployment of 3G. And of course, 3G already has a lot of capacity, as you say, but we just think that for some time-critical usage in smart grid, for example, fiber or 4G present better performances in latency, for example, or in capacity that are useful. But of course, with 3G, you can already do many things. And the smart meters I showed for the water, they first work with some mesh networks. And then from the concentrator, they use 3G, and it's perfectly fine.
I guess just as a follow-up, do you have any plan, like DataJack, of making less expensive communications available on a lower bandwidth platform?
You know, as you've seen, we are in a highly competitive industry. And maybe you know that in France we had a 4th entrance, Free, who has really helped the prices go down. So we are trying, to all the time improve, first on one side, the quality of service for the capacity and the latencies, but on the other side, we need to keep prices low. Yeah, so of course the prices in telecom industry, I would say, they really can only go down and down. Yeah. That's what we see really in the picture today, and that's why there are so many changes coming in the telecom industry with some major purchases at the moment, because there will be certainly a concentration of actors due to the price fall down.
Thank you. Let me ask as a moderator, I guess I can overturn other questions. So let me ask a question for all of you. I mean, it appeared in your presentations that there are the technology is there, or the technology is indeed moving forward. Okay, but then again, we heard in the morning, yes, we are adapting it, but then not a whole lot of cities are adapting the technology. So what are some of the major barriers for adoption of technologies? Is it just regulatory? Ron, you mentioned regulatory and other type of barriers, or like Arshad mentioned, is it more of a human barrier that's out there? I mean, what are the barriers that need to be crossed, both in the long term, in the short term, and the long term? So let me go with who'd like to take a first shot? Maybe Michel, you?
Well, if you talk about the barrier to deal with the smart city system, on the technology, I think you're right to say that the regulatory is one of the first concern, because you have to have the, I would say, the appliance to the regulatory system. And for the moment, the supplier are trying to find the good standard for that. But for the customer, and we saw a lot of things this morning, I think there is 3 major challenges that we have to face. The first is the access to data. The access to data is really something that is raised in this topic, and the interconnectivity of this data is really a key issue for that, which needs to be worked. The second, for me, is it has not been said very clearly, but it is the governing scheme. What do we look at? What do we really need? And what is the target of the mayor? We are working on different demonstrators in the world, and the objectives are different for smart cities. It's different in Singapore, it's different in Lyon, it's different in Danville. So we have to make sure that we focus on the good challenge asked by the governing scheme, and it's not always the same. And the last one, and not the least, is who's going to pay? What is the cost of this equipment, and will it add value to the system? So I think it's not the technology, but it's much more the use and the way to add value. And the theme of this conference is a good one.
Thank you. Arshad? Good.
I think it depends on the technology. If you look at carbon capture and storage, CCS, yes, it's a technology issue. We do not have technology at scale that will allow to do carbon capture and storage at an affordable way. So, but in other areas, I'll give you an example. For you guys, California, you know you're going to have an earthquake. You know that earthquake will impact the electricity infrastructure. How are you going to get emergency power? Go to Home Depot and buy a standby generator that's noisy, that has already caused 9 deaths in Northeast? Why can't I use my PV as an emergency power source? Why can't I use a Toyota Prius that already has an engine? And that, forget about electric vehicle, just a Prius. It has an engine, it has an inverter. It needs some outlets, it needs some more adaptation. In that case, I think we just don't think in that way, and that's why we don't have those technologies. We just assume these things will never happen. So it's a combination of people's understanding of what we need. It's a combination of not having technology. And if you're going to deploy technology in a regulated environment, then yes, you do need the proper regulations and market.
Thank you. Nathalie?
Yes, as I mentioned, I think the business model is really the big issue in some sectors. If you look at the smart transportation, for example, everybody would like to have multimodal information. If I'm in the south of Paris or San Francisco, I would like to know what's the best way to go to the north. But I'm not really ready as the end user to pay for that. So who's going to pay for that? Is it going to be the city? Is it going to be one of the transit authorities? I mean, here you have a real issue of business model. Maybe for smart grid it's a bit different because they are operating benefits. But what I believe is that the first projects we'll see to be deployed will be the ones who have a certain return on investment, not too long. And then others will be much longer to develop because the return is not there. Another issue apart from the business model that we mentioned was the data privacy. I think our citizens are very concerned by this, and I think we have to be very careful because otherwise there could be some rejection. Because we are all in a geek world, maybe we are a bit biased. I think we have to understand that if 50% of the people have smartphones, it means 50% of people don't have smartphones. So, as was said by Melanie Nutter, you don't want to leave these people aside. And this means that for at least 10, 20, 30 years, maybe, you will still need to keep some more traditional ways to provide some services. To give you an example, I was discussing with SNCF, the French Railway Authority, and they said, well, that's very nice what you can provide to us in terms of technology for our train stations. But don't forget that I will still need to have an access to my train station to disabled people and to people who don't have any smartphones. So I need to keep my investments, for example, in usual signage. I cannot have only indications on the smartphones how to get to my train. So of course there will be some quite long period where you need to have both systems, and then you're not making so much savings than you would like, because you cannot have everything disappear like this in one day. The last thing I think I would like to mention, where we are very cautious at Orange, is the social impact. because we see in the machine-to-machine world that more and more you want to replace a connected machine. You want to replace a human person. And as you know, in Europe with the crisis, of course, we are very sensitive to this kind of thing. So you need to make sure that you're creating some jobs, which are different, but creating some jobs instead of replacing just massively jobs that are there today and that are useful. And I was very impressed when I went to Japan this summer, because they are implementing a lot of smart city projects, but on the other side, they are keeping a lot of little jobs, small jobs. So people really keep jobs, and they are there. You have human presence. And on the other, at the same time, you have an automation of things. So I think that would be kind of an objective to keep, because we don't want to dehumanize our future city by making it smart, but with no human beings.
Good point. Ron, any comments, additional comments?
I would say that the two biggest drivers of smart anything, city, grid, et cetera, are economic imperative and crisis. I think in my experience in the 2 years where those two exist, we see demand for solutions. So for example, 2 years ago I went to China and toured one of our customers' factories that made streetlights. And we started at 11:30 and we went around. It come to be 1:15. The guy's looking at his watch and kind of saying, "Oh, come on, let's go out of the building." And finally I said, "Well, what's the rush?" He says, "Oh, at 1 o'clock the power is going to go out and the 1,000 employees are going to leave this factory, go down the street and go to another factory where the power is still on." So, and I sort of asked him about this. Yeah, there's power rationing and it's a big problem from an economic perspective. So I made a decision there and then that Echelon was going to invest in Salesforce in China, because I knew our technology for managing demand and balancing supply and demand would be well received there, and it has been. Second is Japan, the Fukushima crisis, or in the future I predict Hurricane Sandy will spur a bunch of investment in smart city and smart grid technology, because for the next few years we'll remember those two tragedies and we will upgrade as a consequence. So I think those are the principal ingredients, and obviously we don't want to manufacture either one of those, but we want to look to those places where they've happened, I think, for the fastest technological benefits.
Sometimes we do forget, right?
We do.
Yeah, 3-4 months, Sandy will be just something that happened.
I went through Loma Prieta.
That's right.
And within a few years, we've forgotten.
Okay, we are open for more questions from the audience. Do we have any hands up? There is one over here.
I'm Paul from Smart Future. I'm working with the EDF in standardization for electrical vehicle. And I have a question on smart grid and energy efficiency. Today, most of the smart grid objective is to improve the networks and not to improve the energy efficiency. And the difference is seen today as a major difficulty for the householders to get involved into smart grid programs, because they don't save anything. This is the problem of the network. They have to improve the network. This is not my problem. So that is what they think of it. And I believe the next challenge for the smart grid program will be to make understand to householders that they will save energy. And this is very difficult, because for a smart grid network point of view, optimization of the grids doesn't mean you save energy. You may have to use more energy depending on the time. So it doesn't mean that you will save energy. So for me, the next challenge is how a smart grid could go into a smarter house at a good price and a good return in investment.
Okay, who'd like to take a shot at it, please?
Well, I just can start, but
yeah.
you are right to correct. And for the smart grid, you are right. The smart grid, smart meter needs to secure the grid and to make sure that you've got the good availability and also the good use of this grid, because you can balance the electricity, not to have so aging place and to maintain your grid. But you have a good impact on the population on this. First, as we saw from your PEPCO system, you can know very quickly where is the problem, so you can solve it directly and provide the customer a quicker recovery of the electricity. And also you can balance the use of electricity, and you can reduce the possibility of maybe in long term of the cost of the electricity. But you're right, this is some meters are specifically for the grid. What we try to do now is to have a mix on this meter, that is to say, to provide services to the customer. And you need to adapt sometimes the meter, and you need also to have the agreement of the customer to make this, which is also some points that we have to work with. But first step was to secure the network. Second is to provide the customer additional services.
So I'd say there's two trends that will impact the efficiency of the grid. One is once smart meters are in place, you can use time of use pricing to shift peaks into troughs. And if you do that, then you don't have to bring on very expensive, peak supply, peaker plants. So that does make the grid more efficient. Second, you can give real-time information to the consumer as to their consumption of electricity and how much it's costing, or more importantly, their consumption of electricity relative to their neighbors. Because it turns out you will respond more quickly to being shamed in your neighborhood by using more electricity than others. And the smart grid allows both of those things to happen. Now, they're both in their infancy because we're just putting the infrastructure in place to deliver those benefits, but they will come over time. The other part of the smart grid, of course, is investment in the grid infrastructure itself, which allows us to reduce theft, which in some cases 25% of the electricity is either, is stolen. And if we can account for all that, guess what? The efficiency of the grid improves, more people are paying for it, and less overconsumption. And the second is we can dynamically optimize the voltage and so on to ensure that the technical losses are as small as possible.
Okay, Ammi, just on that point, we have the gentleman who leads our program in this area, Omar Siddiqui, is sitting right there. Omar and his team did a project last year that looked at all the different efficiency stream that comes out of smart grid. If you think about smart grid both as smart appliances, smart meters, and smart grid. So that report is publicly available for any of you guys who want it. Just Omar can send it to this group and you guys can download it. It's a very fact-based documentation of all the efficiency improvement opportunities that you can get from smart sensors, connectivity, and smart grid.
Okay. I have a question for Nathalie and Ron. I would like to know how you proceed to develop new technologies. Are you firstly assessing that there is a need, or do you want to create the need? For example, Nathalie spoke about connectivity in car, Currently, I don't need that. But are you hoping that when the technology will be able, I will run to the shop to buy it?
Well, connectivity in cars, as I was mentioning, we see more and more some needs, some people who are interested to have more connectivity in their cars. But we see also the good impact of regulation, which is that the European Union has decided they want to save several thousands of lives per year, and they want to have each new model of car from 2016, which will have an emergency call system. So that means you are in a rural area, you just have you faint or whatever, your car will call automatically a number, a secure number, and so the emergency services can come quicker. So I think in that sense, legislation like the 320s one is pushing for adaptations. But what I could say also is that behind the scene, we have researchers about 3,000 in France Telecom, whose role is really to try to feel about what's going to happen in the networks in the 10, 20 years to come. So if I take the example of the commercial project that we have launched 2 years ago in the Paris area for the water smart meters, this comes from research from about 5 years ago on specific low-power radio networks. So this was enabled by really R&D. So my program is really a business unit, trying to do commercial projects, pilot projects, but also working really ahead with our innovation people. And this means that between a commercial deployment and a research, there's several years, like 5 years. You know. So I would say it's both ways.
Both ways.
To answer your question.
Okay. Quick, it reminded me of a quote. If you ask people what they needed, would they have said a faster horse or a car in 1920? I think they would have said that they needed a faster horse, not a car.
And no one wanted a Walkman.
And nobody wanted an iPad. I already had an iPhone. I already have a Mac. Why do I need an iPad? But I have one, and most of you guys have one too. Sometimes the contrarian happens, and the need is created by visionaries like, by the way, the first quote is from Henry Ford. And then Steve Jobs, you know, the guy over here, he created the need. He didn't ask the people what they needed.
I would say as a 200-person Silicon Valley technology company, it is very hard to create the need in a regulated, sort of highly politicized industry. And you know, maybe it's specific to Echelon, but you know, we thought we were creating the need in 1988 when you know we invented a local operating network, and it has been such a challenge to get you know sort of the industry to adopt it, and experimentation just doesn't happen in these large-scale regulated, controlled industries. So so we've had to unfortunately be more responsive to the stated need as opposed to the fundamental problem. I wish it were different, but I haven't figured out how to make it so.
Question there?
Steve French from Georgia Tech. I think this is probably for Michel and Arshad primarily. We thought a lot about the smart grid and are starting to implement it. And a lot of folks think that opens up the opportunity for distributed power generation, things like PV, microturbines, maybe even small-scale wind. Do you see that as really playing a major role in terms of power generation, and how do you see distributed systems in terms of improving resiliency of the overall network?
Well, if I get where your question is about the way we can integrate intermittency in the network, and the way we can use this new technology. We are integrating all this new technology in the network, PV, microturbine, and with the spirit of having the most balanced use of electricity and reducing the peak, and also developing some storage. We talk about storage in battery for cars, for example. There is, in Europe, there is a target of 60% renewable energy in the network, which is a really very heavy and difficult target to meet. So we are studying this kind of target with our R&D team, just to see what is the challenge we have to face with this. For the moment, we think that 20% is easy to achieve on the network because we have a lot of interconnection. But to go higher on this is necessary. We need more information, more connection, more anticipation about what are the different uses of this different renewable energy. So I think it's not an easy question now, and we are studying, but we are confident that it can increase more than 50%.
I think the way we see this is two different approaches. One is on the generation side. So if PV, microturbine, fuel cell, you name it, I think unless the cost comes down from a generation perspective, without incentives or without regulations, they will not happen. But the opportunity that we see of research and development is the operation of microgrids, which is, can we design a microgrid that can work in parallel with the utility when the utility is present? Because you can make a microgrid as reliable as a large central system, but when a utility is not present, can you adaptively shed load and manage your local generation, your local load? We cannot do that with the rooftop PV today. I mean, I'll challenge Georgia Tech. I'm challenging our EPRI engineers. Why can't I adaptively shed load in my house and manage a rooftop PV and load in a dynamic basis as if my house is its own grid, only during the time when I don't have power? So it's a load management challenge, and we haven't figured that out yet. So it's two approaches, grids, the management side and the generation side, which is make the next best fuel cell, make the next best PV, and continue to push the cost down.
I have a last question. This morning we spoke about the commitment of the industry and also the commitment of cities to develop smart cities. In Europe, in the US, is there also a political and financial support from the government for that, or cities and industry are to deal that alone?
Yeah, maybe I can answer. Of course, companies have to invest on the long term, and we think that's necessary. We think we need to anticipate, so that's something we do. But I must say that there are also some programs in France, like was mentioned, the future, what they call the future investment was mentioned by the ambassador, Investissement d'avenir. And for example, maybe some of you know that in France we try to push a lot near-field communication solutions for payments, for example, for transportation in shops. And here there are some support from the government through this program to support, I think it's 9 cities have been chosen to launch programs with NFC. So yes, there are some supports, but still companies have to invest themselves on the long term.
In the U.S.?
I would say in the U.S. It's quite a challenge. From a smart grid perspective, we have 50 regulatory bodies called state public utility commissions, and they all have a different set of requirements and marching orders. So it's extremely hard, certainly for a little company, to advocate and to try to get some convergence on standards and that kind of thing. At the federal level, there's no mandate equivalent to the Europe 2020-21. When the government tried direct investment, a la Solyndra, that didn't work out very well, and some argue that the smart metering programs in the United States didn't work out exceptionally well. So it's quite a challenge. I would say here in California, the government's a little more far-sighted, and there have been some recent initiatives, solar rooftop initiatives and renewable energy objectives and so on, that I think are a step in the right direction, but I think we're far from standardizing at the federal level the way we would need to spur innovation.
Yeah, I could add maybe that I talk about some French funds, but there are also European funds. Yeah. The issue is a bit similar to what you say, is also the conditions that are put there to use these funds for some experiments are really quite hard to meet. So I would say in some cases, sometimes you'd rather invest yourself because there are like tens of lines. So we hope that this can be more flexible in the future.
Thank you. Okay. Thank you very much. Let's get